In this class, we are going to discuss one of the topic called charge to the mass ratio of the electron. So, the scientist called J.J. Thomson, he determined the charge to the mass ratio of electron by conducting experiment in which he took one glass tube and he placed two electrode. One is cathode and one is anode. Cathode means negative charge, anode means positive charge. And he connected both electrode with a voltage, collected with a voltage. When connected with the voltage, the electron started to move. In my previous class, we have studied that the when we connected to any voltage, the particles started to move from where to where, from negative to positive. They are started to move from negative to positive. You are saying this is the ray. When it connected, it started to the moving the particles, and he after he first he placed an electric field. This one is electric field plus, and this is negative. These parts are electric field. When he placed the electric field, he absorbed a slight deviation in this ray. He absorbed the slight deviation in this ray, and we can see that the straight line get deviated and fall on the point A on fluorescent screen. So first, when he placed the electric field, so next he removed that electric field. Next, he placed magnetic field. When he placed the magnetic field, that ray started to move continuously, and one certain point, when the magnetic field is applied, it start to deviate towards the sea and fall on the point C on the fluorescent screen. First, he placed the electric field. The ray started to pass. When passing to the electric field, it slightly deviated to the point A of the fluorescent screen. After he removed that electric field, next he placed the magnetic field. That time it started to deviate towards the point C on the fluorescent screen. And next, what he did, he applied both electric field and magnetic field equally. Not both equally he applied. He placed. Then the ray started to move straight. Then the ray started to move straight. Any deviation not absorbed. When he applied electric field and magnetic field equally, there will be a straight line, and it falls on the point B on the fluorescent screen. From this we in the previous class we have observed that the without any electric field and magnetic field, the rays started to move straight. Like that only, when placing the magnetic field and electric field equally, then also it behaves like same as it is in the absence of electric field and magnetic field. So these is depend on 3 points. First is magnitude of negative charge on the particles. The particles which are moving now, how much negativity on that? If the more negativity, more will be deviation. If the particles which was moving from this point, if it has more negativity on that particles, it will be deviate more. If less negativity, it deviate less. This is the one points depend on the deviation. So second is the mass of the particles. If the mass of the particle is less, it deviates more. If the particle mass is more, it deviates less. If for example, if we throw two stones, which one is lighter, which one is heavy, which one will be reach uh, far away from us? The lighter one, because that like only here, when the particles are moved, the lighter particles get deviated more, and the heavier particle, if the particle size is mass is more, the deviation will be less. The third point is the strength of electric and magnetic field. It's also depend on the strength of magnetic field and electric field. The strength what we are applying electric field, the strength will be more, the deviation will be more. When the strength of the electric field is less, the deviation will be less. And same as it is, if the strength of the magnetic field is more, the deviation will be more. If the strength of the magnetic field is less, the deviation will be less. These are the points on which the deviations depends. From these observation, our J.J. Thomson gives the charge to the mass ratio of electron, charge to the mass of the electron, which is 1.758820 into 10 to the 11 coulombs per kg. This is the charge mass ratio of the electron when we place in the magnetic field, when we place in the electric field, how much deviation occurs. No, by observing that, he concluded, he largely given the charge to the mass ratio of the electron. After that, our one more scientist called RA Millikan, he conducted one experiment called oil drop experiment. From this oil drop experiment, he given the charge of the electron. He given the charge of the electron, which is 1.602176 into 10 to the power of minus 19 coulomb. So we got charge of the electron, we have charge to the mass ratio of electron, then we can find the mass of the electron by dividing first charge of the electron divided by charge to the mass ratio of electron is 1.75882 into 0 into 10 to the power of minus 11 coulombs per kg, and the charge of the electron is 1.60217 into 10 to the power of minus 19 coulomb. By dividing, we will get the mass of the electron, which is 9.1094 into 10 to the power of minus 31 kg. This is the mass of the electron.